Assalamualaikum warahmatullahi wabarakatuh. Today we are going to learn chapter 2, that is differentiation for derivative of a function. At the end of the lesson, you should be able to find the derivative of a function using the first principle. So what is differentiation? The process of finding the derivative of a function is called differentiation, and we can denote it as dy over dx as derivative of y with respect to x, and it is also known as a gradient function. Sometimes we can write dy over dx as f prime x or y prime. Okay, so what is the first principle of derivative? We have the formula, that is dy over dx equal to f prime x equal to limits delta y over delta x as delta x approaches to 0. It is equal to limit f of x plus delta x minus fx over delta x as delta x approaches to 0. To make it easier, we let h equal to delta x. Therefore, f prime x is equal to limit of fx plus h minus fx over h as h approaches to 0. Or we also can write down like this, that is f prime x equal to limit 1 over h as f of x plus h minus fx as h approaches to 0. So let's do the first example. Differentiate each of the following by using the first principle. So the first function is fx equal to 3x. Okay, so first we find fx plus h. It is equal to 3x plus h. And then we can expand, we will get 3x plus 3h. Okay, next, substitute into our formula, that is f prime x equal to limit 1 over h of fx plus h minus fx as h approaches to 0. We will substitute fx plus h, that is 3x plus 3h minus with fx. So fx is 3x as h approaches to 0. Then we can simplify. 3x minus 3x is equal to 0. So limit 1 over h of 3h as h approaches to 0. So now we can simplify h. So we'll get limit 3 as h approaches to 0 is equal to 3. Okay, so for the example 1b, the function is fx equal to 2x squared minus 2. Okay, so we'll find fx plus h equal to 2. So substitute x plus h squared minus with 2. So we expand x plus h squared, we will get x squared plus 2xh plus h squared minus 2. Then we will expand. We'll get 2x squared plus 4xh plus 2h squared minus with 2. Substitute into the formula. So f prime x equal to limit 1 over h of fx plus h minus fx as h approaches to 0. Okay, then we can substitute for fx plus h, that is 2x squared plus 4xh plus 2h squared minus 2. Okay, minus with fx, that is 2x squared minus 2. Okay, we can simplify. 2x squared minus 2x squared is 0. Negative 2 minus minus 2 is positive 2. So you also can simplify here. So we'll get limit 1 over h 4xh plus 2h squared as h approaches to 0. So we can factor out our h here. And then we'll get 1 over h. Okay, factorize h. We will get 4x plus 2h. And then we can simplify our h. So we'll get limit 4x plus 2h as h approaches to 0. So we substitute h equal to 0 here. So 2 times 0 is 0. So now you'll get here is 0. And then we'll get 4x. So this is our final answer for 1b. The last example, that is gx equal to 1 over x plus 1. Okay, so firstly, we find gx plus h. This equal to 1 over, okay, substitute x with x plus h, then plus with 1. Then substitute into our formula, g prime x equal to limits 1 over h as gx plus h minus with gx as h approaches to 0. Okay, so substitute gx plus h. So 1 over x plus h plus 1 minus with gx. Our gx is 1 over x plus 1. Okay, next what we should do is we need to equating our denominator. Okay, so now multiply here x plus 1 multiply with 1, you will get x plus 1 minus with x plus 1 plus h. Okay, don't forget to write down our bracket here. Over x plus h plus 1 times x plus 1. Okay, next we can simplify. So x minus x and then 1 minus with 1. So balance we will get negative h over x plus h plus 1 times with x plus 1. Okay, then we can simplify h. So finding the limits of negative 1 over x plus h plus 1 times x plus 1. Okay, then we will substitute h equal to 0. So this one is equal to 0. Okay, then we will get negative 1 over x plus 1 times x plus 1. Or we also can write down negative 1 over x plus 1 squared. Okay, so this is our final answer. Okay, so that's all for today. Okay, don't forget to do your exercises for this one, for this chapter, that is the first principle of derivative, and you must turn in your work to your lecturer. So that's all. Thank you guys.